Hello everyone, this is Barka Technical Solution and I am Firdaus Rahman. In this video we are going to see how to create an home automation system using an ultrasonic sensor and an LED. So what this will does is actually it will detect if any object is in a closed parameter. So if any object or person cross that parameter, the LED will indicate that. So we are going to create it. So this is our circuit that's how we are going to actually create all of this. So let's see what we have done here. So this is our ultrasonic sensor, the HCSR04, and this is the SMD LED I am going to use. So here I have done all the wiring. So the first thing is that we are going to connect all our VCC pin to the 5-volt pin of our Arduino, and the ground pin of our ultrasonic sensor and the RGB and our RGB LED to the ground input of our ground pin of our Arduino. So both of them goes to these two ground pin. Then we are going to connect the trick pin to the pin number 11 and the echo pin to the pin number 10 of our Arduino, and we are going to connect the RGB all the three R, G and B pin to our Arduinos respectively to pin number 3, 5 and 6. So that's all in our circuit. So now let's go and see how we can actually program the Arduino to make it all of this happen. Now we are in our Arduino IDE. So here we have our code that we will be using to control the ultrasonic sensor and our LED. So in this case, as we are using a SMD LED, which is an which is also an RGB LED, so we have to use both of them connectively. So here the first thing we have done is, for the ultrasonic sensor we will need to include that library for the ultrasonic sensor, which is the new ping.h. So we have included that first. Then we have defined the trick pin and the echo pin, which are on 11 the trick pin, and in the 10 number pin is the echo pin, and we have set the maximum distance to 20. Then we have created a object naming sonar, and we have included the trick pin, the echo pin and the max distance in that object, and then we have defined the RGB pin for our SMD LED. The red is the pin number 3, green is pin number 4, green is pin number 5 and the blue is pin number 6. Then we come to a setup part. So here I have set up the serial monitor, so we can actually see the distance from the serial monitor in here. Then I have defined a delay of 100 milliseconds, so we can actually see all the distance index. Then we are going to set all the pins to its individual output or input mode. So for the trick pin it will be output, or if I can easily say it, except the echo pin, every other pin will be set to output except the echo pin, as we will be taking it as an input, because the echo pin will receive the sound wave that we will be producing from this trick pin. So the echo pin will be in input mode. Then we come to our while loop part. We have all our main code here. So the first thing we are going to do is we are going to set our trick pin to low for 2 microsecond. So it's not milliseconds. So we are going to write delay, then capital M, and then we are going to write the microsecond with capital M. So the delay microsecond will actually means that it will have a pause of 2 microseconds. Then we are going to write digital write trick pin, and we are going to set the trick pin to high for 10 microsecond. Then we are going to set the trick pin to low. That means we are going to turn off our trick pin, and by making the echo pin high, that means it is now on. So what it will do is, the sound produced by our trick pin from this phase to this phase, or between this 10 microsecond, what it will do, that the echo pin will now receive the sound wave if there is any object in front of the trick pin then the sound will bounce from the trick pin and it will bounce back to our echo pin, and it will receive, and the sound wave will be now received by our echo pin from here, and it will be sent to this pulse in function, which will actually calculate the length of our sound wave. Then we are going to keep that in our duration variable, which is an integer variable. Then we are going to do this, then we are going to take our duration and we are going to divide it by 2, and then we are going to, so we get the so now we get the distance from the trick pin to the object that was in front of the trick pin. We are going to divide it by 2, as it will have to travel twice from trick pin to the object, then from the object to the echo pin. That's why we are going to divide it by 2. So that's our distance. Now we are going to divide it by 29.1. So this is the time that takes a sound wave to travel 1 centimeter in the air. So it is actually in microsecond also, 29.1 microsecond. So we are going to divide this duration or the distance by this 29.1, so that we are going to get the distance, which will be saved in this distance variable, which is an integer variable as well. So we are not going to deal with any kind of float or long or double variable, because we don't need that much precision. Then we are going to set the condition to light up our, to turn our lights or our LED light on. So if our distance is greater than 10, the red LED will be on, as I have set the red LED to high, and else which means if it is less than 10, other than that the red LED will be turned off. Also the blue LED, as it is a RGB light, we have to turn the blue LED also off, only the green LED will be on. So I have set it to high. Then we are just going to write all of this to our serial monitor. We are going to write the distance in the serial monitor, and then we are going to write centimeter after that distance we are going to show in our serial monitor, and then we will be having a delay of 500 milliseconds. So if I can show you here, as you can see, there is the distance, then we are seeing it in centimeter. So as you can see, now it is less than 10 centimeters, so the LED is now red. If I go over 10, the LED will be green. So this is our circuit that we are going to build. So here, as you can see, this is our ultrasonic sensor, this is our LED, and what I have not included in my diagram, circuit diagram, that is this 3 resistor that I am using. So you just have to connect this resistor to the RGB pins of this SMD LED. You don't have to connect it to this last one, the minus one. So it is the ground pin of this LED, which will be connected to the ground pin of our Arduino, and this ultrasonic sensor, the VCC, will be connected to 5-volt pin. So here, as you can see, I have connected the red wire to the 5-volt pin, the other 2 is connected to this 2 ground pin. So one of the ground pin, which is the white one, is the LED, and the black one is this ultrasonic sensor. So the trick pin and echo pin, so trick is the green one and the echo is the blue one. So these are connected to pin number 10 and 11, and the RGB pins are connected to pin number 3, 5 and 6. So that's all. So I have already uploaded the sketch to this Arduino. So if now I connect it to my PC, as you can see, the LED is green because there is nothing in front of it between 10 centimeter. So if I put my hand in front of it, as you can see, the light turns red. The LED is red, as it has detected that something is in between 10 centimeter. So if I remove my hand, the LED is again green. So that's how it's actually working. So it works perfectly almost every time. So So thank you everyone for watching the video. So thank you everyone for watching the video. If you like this video, please hit the like button and subscribe for more videos.